Hello everyone, welcome to Coding Digest. In our previous session, we discussed about arrays in Java. What are the properties of arrays, how to manipulate arrays, etc. Right? What is array? So array is arrays are basically a data structure like this, right? Where you can store multiple data, right, using a single data type, okay, or single entity, right? Single entity, suppose this is my string array, right? String array arr equal to this. So all the strings can be stored here, a limited number, not all the, but a limited number, or known number, not also limited number, but known number of strings can be stored here. Now here the disadvantage is uh, the arrays are not growable in size, and arrays can handle only homogeneous data type. What is homogeneous data type? Homogeneous data types are like string, right, like int. So any array cannot hold more than one data types, like more than I mean an array can contain string as well as integer as well as float. It's not possible, right? So it can add the two most important disadvantages of the string or of the arrays are: it can handle only homogeneous uh, data types, right? And it is not growable in size, it is fixed in size. The arrays are fixed in size. Now, first problem, it only contains the homogeneous data types, right? So what is homogeneous data types? Now suppose this is the homogeneous data types. Suppose string, okay, string is one data type. String array, let me declare one array string, and a b c, sorry, there will be comma, and then uh, d e f 1 2 3. It is not possible, right? But it is possible. How? If we declare an object type string, then you can put any kind of abc data type here. Suppose a character, and suppose 1, any kind of data type you can put in this particular array, because object is the parent of all the data types, like string, like integer. Okay, so the structure is like this: object, it has many data types, it is a mother class of all the classes, like integer, float, double, string. So all the classes are belongs to this object class. Okay, then if we declare the array with object array as object, as an object array, then we can put any kind of data, right? Any type of data. But the it is fixed in size. That problem cannot be solved. Arrays are fixed in size, and that problem cannot be solved. That is why Java came with a solution, right? That is called collection framework. Collection framework. Okay, collection framework. What is collection framework? It has some hierarchy. Okay, collection is basically an interface. We discussed about interface, right? So collection basically an interface, and collection manages to create some growable in size data structure, like growable in size arrays, growable in size set, growable in size queue, right? So those all are growable in size. Okay, those are not fixed in size, because suppose you are getting some data from database and you are storing uh, those data into your data structure, local data structure like arrays or collection, whatever. You don't know how much data is there in your database or in your backend. So for that, you need some growable size data structure, correct? So for that, Java came with the solution of collection framework. Let's move forward. So collection, again, collection is an interface. I already told you, collection is an interface. Okay, this interface implements another implements, or rather it's a child, not implements, actually extends another interface. That means it's a child interface of iterable interface. Okay, iterable interface. Why we need iterable interface? To iterate uh, the collection data structure, growable in size data structure. That's it. So collection interface, the child interfaces of collection interface are, there are three things main: list, queue, and set. So all these are interfaces. Okay, all these are interfaces. Now what is list? What is list? Now list is an interface again. So list has a structure, or a linear data structure, right? Linear data structure, array like structure. List has a array like structure, right? Now how it is growable in size? This is very important concept. How this collection framework implements these growable in size things. So what Java does is it creates a smaller array first. Okay, you are putting some data here, here, and when it exceeds, right? It has a fixed size. When it exceeds, it creates a bigger size array. Okay, a bigger size array, which is 10 times of this. Let's suppose 10 times of this particular array, and it copies all the elements one by one. It copies all the element one by one to this bigger array, and this process goes on until all the elements are fit inside the array, inside the list, basically this linear data structure. Okay, this is how they implement this growable in size concept. Okay, so what is the benefit? Benefit is collection is it has a growable in size things. What is the disadvantage? Disadvantage is, see, it is creating a smaller array first, then it is copying all the elements, right, into the bigger array, right, into the bigger array. So what is happening here? The smaller array is going for garbage collection. Okay, is going for garbage collection, which again garbage collection cannot be called explicitly, right? It is JVM's internal memory system to call garbage collection. So it will go to heap memory, right? It will go to heap memory. Heap memory. I already discussed what is heap memory, what is stack memory, right, in my first class or in my initial classes. So it goes to heap memory, and again it may cause some memory out of memory full exception basically, right? And then what happens is it copies all the data from one array to bigger array, which again takes time, which again takes a good amount of time basically, right? Which again takes a big amount of time or good amount of time. So the performance wise this is also not good. Okay, and think about another scenario. So here suppose there is a 5 elements and you want to put 6 elements. Okay, 6 elements. So the 6th element you will put in the bigger size array, because the initial uh, array size was 5. You are putting 6th element here. You do not have any other elements. So only 6th element, only for this 6th element you are using this bigger 10 times bigger array, which in turn causing a wastage of memory. So all these after 6 to all these whatever is pending are all the memory locations are wasted, and it cannot be reused. So for performance wise, always array is required. I mean, always array is recommendable, not the array list, or not array list, or the collection framework. Okay, so any collection framework works on this particular theory basically, right? So performance wise it's not good, but growable in size, if we want some growable in size data structure, we have to use collection framework. So if you know the data size of the data, always recommended option is using the array, because it saves lots of memory. But if you don't know the size of the data, then obviously you have to use collection framework. Okay, let's deep dive. So first thing is, let's discuss about list. List. Okay, as we know, list is an interface, right? So you cannot use any interface directly. So for that, what we need, some implementation classes. The implementation classes of lists are array list, array list. Okay, this is a class. Linked list, this is again a class, and a vector. And the child class of vector is called stack. Okay, this is the structure of list interface. Okay, so what is array list here? Array list I just showed you, right, how the structure is. It is like an array. It initially creates a smaller array, then eventually it creates a bigger array to accommodate bigger data size, or bigger number of, or larger number of data, correct? And this particular smaller array will go for garbage collection. Okay, so this is array list. Okay, this is a linear data structure. Now what is linked list? Linked list is kind of a train. Okay, it is linked, the memory locations are linked with each other. Okay, these are called the nodes. These are nothing but memory locations. Okay, these are called nodes. Now this node contains three rooms, basically, you can say. So first room, second room, first room, second room, third room, first room, second room, third room. So this particular portion contains the address of previous node. If it is first node, then it contains nothing. It's blank or null. Okay, this particular code contains actual data, and this particular thing contains the address of next node. Okay, and it is linked with this. Again, this contains the address of this particular node. This is the data, and this contains the address of this node. Again, like this can be, I mean, this will form a train like structure, which is called linked list. Now the question is where to use array list and where to use linked list. If you see the structure of array list, it is a linear data structure. Okay, and it is a index based structure. It is the index based structure, means it has it is very easy to traverse the list. Suppose you have 1,000 elements in this particular list, right? And you are traversing to the 750th element. You can easily do that. In case of array list. But if you think about linked list, okay, if you think about linked list, it will first call the first node, then it will call the second node. Second node means it will check for the address of second node, then it will go to second node and will check for the address of third node, and so on till 750th node. Correct? So the performance wise, this linked list is less efficient when we are traversing from start to end. Right? Now, so for traversing, array list is recommended, not linked list. But when you want to delete or insert or delete in between the array list, right? If it is if you are adding some data in front or at the end, that is fine. That is fine for both of the lists. But if you are putting some data or you are inserting some data in between some nodes or in between some data, right? Then array list is not recommended, because what will happen in case of array list, it will create again up to this, it will create a list. Okay, suppose you want to put a data here. Okay, let me draw here. Suppose this is my list, array list, right, and so on, and I want data to be here. So what will happen, it will again create a bigger size of array list or array, mainly the structure is array, and then it will create a new array list. So it is not memory efficient, and obviously it will copy all the data, right, and create all these things. So it is obviously not the memory efficient, it is obviously not the performance efficient, time efficient. Correct? So if we want to insert or delete array list or is not recommended, but think about linked list, right? Suppose linked list structure is like this, okay, it is linked with another doubly linked list. The structure is called doubly linked list structure. Okay, this is suppose my linked list. Now I want to delete this particular thing. So what I mean this particular node. So what I'll do, I'll simply detach this particular node by deleting this address from here and this address from here, and it will go for garbage collection and it will be connected directly to it. Got it? So this is called linked list conception, and linked list is always recommended when you are inserting or deleting some data from middle of the collection, middle of the list. Clear? Now vector. What is vector? Vector. Vector is nothing but array list. Okay, it is simply same as array list. Okay, with synchronization. Synchronization. So what is synchronization? Suppose I have, there is a concept of thread, but I'll cover the thread, multi-threading, Java concurrency, and synchronization in details in a separate video. But for now, just take a look. Like suppose you have a database here or bucket here. Okay, you have some bucket. Now you are person A and your sister is person B. Okay, A and B both are using this particular water. They can do it parallelly, but I want to measure how much water is wasted by each of the person. How to do that? How can you measure that? Because everyone is taking randomly, right? How can you do that? So what we can do, we can do particular. We can make use of some uh, token things, like, or not token, actually sequential thing. Okay, suppose A takes one bucket or one mug of water, and then B takes one mug of water, then A takes number 2 mug of water, B takes number 2 mug of water. So this is called the synchronization. Synchronously A and B are taking the water from the same bucket. This is called the synchronization, and the same thing can happen in Java also. Multiple threads can access a single thing, which is called multi-threading, and we can synchronize those access things. Okay, so this is called the synchronization. So vector is basically the synchronized version of array list, as simple as that. Okay, nothing fancy, nothing different. Okay, fine. Next is set. We'll not discuss queue here, because queue, we don't use queue very frequently. Okay, so for now, if you want it for the interview purpose or something like that, you can go through the queue concept from any of the resources. Resources are available in internet, but queue is not important for programming purpose and for day-to-day things, right? We will use list and set more in day-to-day activity. Okay, So next is set. Sorry. Next is set. So as we know, set is another interface under collection interface. So obviously set has some implementing classes. So implementing classes are hash set and linked hash set. Linked hash set. Okay, these are two classes. Another child interface is there under set interface is called sorted set. Sorted set. Okay, this is also an interface, and sorted a set extends, I mean not extends, there is a child class or implementing class called tree set. Okay, now we'll see how this set works. It's simply kind of a bucket. Just imagine kind of a bucket, and this is element A, element B, element C, element D, element E, element F, like this. So what is that? It is a not a linear data structure, and it doesn't maintain any kind of insertion order or something like that. We have to manipulate to maintain the insertion order. That is why there are so many types of classes, right? So this is element A, B, C, D kind of that. Okay, so if you retrieve in which order these element will come, you don't know basically, but you can retrieve anyway. One thing, and second thing is it is not index based, like unlike the list, right? List has a index 1 2 3 4 5. So using index based for loop also you could fetch some data from this list interface or list data structure basically. But in set you cannot use any index based data structure, not data structure, any index based for loop, because it is not indexed data structure mainly. Okay, to fetch it we need some iterable interface, basically iterator interface or some for each loop. Okay, so this is the structure of basically normal set. Okay, in general set. So now what is hash set? It's uh, very good conception behind this hash set. Okay, so again the structure is same, hash set. The elements are like this. Okay, and these elements, how these elements will store inside this particular back bucket, this element will store based on hashing. Okay, hashing or hash code. Now question is, what is hash code? Suppose you have one string called school, right? Now what is the hash code for this particular school? We'll convert this school into integer. Okay, integer. Simply we'll convert this school to integer. Each and every character has its integer values, so we'll convert those values to integer, and this integer value will be the hash code of school. Okay, based on this hash code, hash set stores the value. Okay, based on these hash codes, hash set stores these values. So what are the characteristics of this set? Set cannot contain duplicate values. Okay, set can only contain unique values, not duplicate value. Okay, it cannot contain duplicate value. This is the main property of set interface. Okay, now In case of hash set, it is the insertion order is not preserved. That means if you are putting some data, it is not guaranteed that when you are retrieving data, it will come as you inserted the data. Okay, in the same order as you inserted the data. It is not guaranteed. It may come or it may not come. Okay, so for that we have one set called linked hash set. Okay, linked hash set. This is a class. So how it works? It works like a linked list theory. Okay, how linked list theory works? Suppose you are putting node A. Okay, what is that? What is this? Is the previous address, this is the next address, next node address. So again you are putting another, sorry, you are putting another node here or data here. So it will, it will store the previous address, previous node address here. So there will be a connection between two nodes or between the nodes basically. So what is the advantage of this particular set? The particular set, the advantage is it preserves the insertion order, because it is the data are linked, or the data nodes are linked to each other. Understood? So linked hash set, so property, one of the property is linked hash set, linked hash set preserves the insertion order. It preserves the insertion order. Okay, it preserves the insertion order. Apart from that, everything is same as hash set. Okay, so next is you have one set. This is interface. Another interface is there called sorted set. This is also an interface, and the implementing class is tree set. Right, tree set. Now, as this particular tree set class, this is a class. Okay, as this particular tree set class implements the sorted set interface, this particular set is sorted. Okay, this particular set is sorted in ascending order or dictionary order. Sorted set or tree set is sorted in ascending order or dictionary order. Right? It is not the insertion order preserved, but it is sorted set with ascending order. Okay, so only sorted set or only sorted data structures in set is tree set, where all the elements, when you retrieve all the elements will come in ascending order. Correct? Okay, fine. So we already discussed that we are not going to discuss any queue things. So what we discussed here in the collection framework, we discussed list, all the list, child classes, actually implementing classes of list, like array list, linked list, vector, stack, etc. And then we have discussed set. all the child classes, or not child classes, actually implementing classes of set interface, that is hash set. The child class of hash set is linked hash set, which is basically similar to hash set, but it preserves the insertion order, right? And another thing is sorted set and tree set. So this is the collection framework, overall collection framework. In the interview, if you are asked that what is collection framework, then you have to elaborate this particular hierarchy, right? So first thing is iterable. It starts with iterable. I'll discuss iterable in detail, how to iterate all the lists. Okay. So first thing is iterable. Then the child interface is collection interface. There are three child interface of collection interface, that is list, queue, and set. In the inside list there are certain child classes or implementing classes, and in the set also there are some child classes or implementing classes. Okay, but queue also has some like dq, right? So those kind of things are there inside queue also, but we do not use queue concept in day-to-day life. That is why I am not wasting time discussing this particular queue concept. If you are interested, then please go through any internet resource. That is fine, right? Now next thing is map. Okay, next thing is map. Map is not directly related to collection. Okay, map is separate entity. Map is an interface again, right? Again, there are certain implementing classes like hash map. Hash map, this is a class, and child class is linked hash map. Just like linked hash set, it has linked hash map. Okay, and another thing is again sorted map. Sorted map, and it implements, it is implemented by tree map. So it is obvious that tree map will be the sorted map. Tree map will be the sorted map, right? Now how map works, what is the structure of map? The structure of map is basically like key and value tabular structure. So if you have some roll number, okay, roll number and name. So roll number is 1, name is Vikash. Roll number 2, name is Suam. Roll number 3, name is let's say Poonam, like that. Okay, so this is called the key and this is called the value. So the data structure stores data in key value structure is called map. It is obviously growable in size. Okay, growable in size. So there is one key, there will be one key, and the corresponding value should be there. The keys, obviously the keys should be the unique values. It cannot be repeated. If you are repeating the key, it will, the repeated key will override the previous key. That's it, previous value basically. Okay, so key should be always unique. Some maps can handle some null key, null value. Some map does not allow null key, null value. Okay, so let's deep dive into the structure. So we have a map. So first thing is hash map, right? So hash map, suppose this is the integer and the value is in string, correct? So what is that? Key will be in integer and value will be in string. You can put any key, any value, I mean data types. I am taking integer as key and string as value. Okay, so hash map is like hash set. It doesn't allow, I mean doesn't preserve any insertion order, and it works on hash table or hashing. Okay, it works on hashing simply. I already discussed what is hashing, right? It works on hashing. Same thing like hash set. Only difference is it has key value pair. Okay, the child class of hash map is linked hash map, which will preserve the insertion order. Because why? We have already discussed in case of linked hash set, because it implements the linked list concept here. The one node is related with another node, that is called the linked list concept, and linked hash map obviously will preserve the insertion order, right? Linked hash map will preserve the insertion order. And next thing is sorted map and tree map. Tree map is obviously a sorted map. Okay, tree map is obviously a sorted map because it implements or not implements the sorted map. How it will be sorted? The sorted order will be ascending again. The key will be the ascending by keys. Okay, ascending by keys. Ascending by keys. So tree map will be sorted map and the sorted by ascending order by its keys. Right? Now there is another thing which is called the legacy class, right? Java, this map concept and all these collection things completely introduced in 1.6 maybe, but there was another concept using the hashing, okay, that is called the hash table. Hash table again, the structure is same as map. Okay, structure is same as map, that is key and value pair. Only thing is hash table is first is synchronized, right? Second thing is it cannot contain any null key and null value. Null key, null values are not allowed in case of hash table, and it is synchronized. Synchronized means I have already discussed, it is thread safe. Okay, I'll discuss this. What is thread safety? what is synchronization in Java, right? So that is a very deep, very important concept in programming. Huh? What is Java concurrency? So those things are needed for programming. For a good programmer, those things are needed. Anyway, so hash table is synchronized and it cannot contain null keys and null values. It cannot contain null keys or null values. Whereas in hash map contains one null key, obviously the key should be one null key, and multiple null values. Okay, multiple null values can be added inside hash map. The same with linked hash map. Okay, same with linked hash map. Only thing is linked hash map preserves the insertion order. Tree map is very tricky. So in tree map, null key is not allowed. Null key is not allowed. Always remember this particular property. Which map doesn't allow null key? It's tree map. Okay, and tree map is not synchronized, obviously, and hash table is not map, but it's a legacy class, okay, which was introduced in Java 1.4, right? And it is somehow connected with map interface, basically. Okay, so it doesn't allow null key. A tree map also doesn't allow null key. Okay, this is very important distinguishing factor between maps. Okay, and based on these properties, you have to decide which map to be used. If you have some null key, you can have some null key, then you have to decide whether you should use tree map or you should use hash table. Hash table is not used because it's synchronized. If you want some synchronization, that is also possible. Okay, I am going to discuss in next few seconds. Okay, so next thing is what is the difference? It's very important interview question also. What is the difference between collection and collections? Spelling is different. Collections, right? So what is collection? Collection is what we learned. It is an interface, but collections are class. Collections is class. Okay, collection is having some interfaces like list, okay, queue, set, like that. Okay, but collections are having the generic methods. Okay, generic static methods which can operate on top of collection interface, like sort. Okay, like sort is one There could be another method called reverse, right? Reverse. Okay. There could be synchronized map. Okay, suppose you have one map and you want to just synchronize it. So how to synchronize that? Collections dot synchronized map. Okay, and inside braces you have to put the map. Okay, whatever map you have declared. So this is how these methods are working. Like inside collections, there are some static methods which works on collection framework. Suppose you want to reverse the order of particular list or particular set or particular queue. So you can use reverse collections dot reverse that particular uh, collection interface, whatever. Like that. I'll show you the examples and all. Okay, there could be unmodifiable methods. Okay, unmodified. You are making some of your collection interface as unmodifiable. No one can modify your data, right? That is called unmodifiable. Suppose unmodifiable list, unmodifiable set, unmodifiable map. If you are declaring those maps as unmodifiable, then those maps cannot be manipulated in the further order. Okay, you can also do some binary search. I'll show you how to do that. Do that binary search in things, right? When I will jump to some lead code uh, solution, okay, in Java programming, then we will see how these binary search works. Okay, this is how collection framework and collections class are working. So what is the difference between collection and collections? It's very important Java interview question. Collection is interface and collections is class. Collection is a class which contains some static methods like sort, reverse, synchronized map, synchronized set, synchronized list, synchronized queue, okay, and unmodifiable map, unmodifiable queue, unmodifiable list, unmodifiable set, and so on, right? Which will work on top of collection framework. Okay, this is one thing. So let's start with some implementation, right? Suppose we have, let's go to code, and let's create one class collection tut.java. Okay, the class. So first thing is what we learned is list. So this is the generics. Okay, list. We are specifying this particular list to be string, and this is available from Java 8 and onwards. Okay, before that it was like this only list. That's it. lst equal to new array list, like that. Okay, there was no generics, but from Java 8 onwards we can have some generics. So how to put that particular thing? String, and again here it is string. So what is generics basically? Generics is you can what is generics basically? Generics means you are uh, putting your class, or you are creating your class in such a way, right, that any kind of data can be managed. Okay, any kind of data can be managed. Like here it is string. Now it is also possible if I want to put some integer type variable inside array list, that is also possible. We have to mention integer here instead of string, that's it. Okay, so how to mention that generics in the class? Suppose this is collect tutorial is a class, okay, and I want to make it generic. So how to do that? It's t, like that you have to put. Okay, it's very easy. I mean, if you I can show, but in next video, right? So the collection tut will can catch or can accept any kind of data, like this. In list interface and list array list class can accept any kind of data: string, integer, float, double, any kind of data. We can create any kind of array lists. Okay, so this is how we declare an array list. Okay, this is also possible. Array list, this is also possible. Array list equal to new array list, because array list is just a class. Okay, it's the implementing class of list interface. So instead of array list, we can also use list here to access better method coverages. So list has some other methods also. Array list also have those methods, but it has some other things also. Okay, so you can do that upcasting. Next thing is linked list. How to do that? List, suppose list of integers, uh, linked list equal to new linked list. New linked list. Okay, so let me put some main method here, and let me create these two inside main method. Okay, and how to manipulate it? So there is a command, there is a method called add. Okay, to add this, add any data into that list. For any list, there will be add method. Okay, and if you want to access some data, it would be dot get. Okay, it could be index based, or it could be anything, any data. So array list is a index based data structure, right? Or linked list is also index based data structure, right? So suppose there are some values over here, right? This is a array list. Okay, okay, and I want to access those data. How to do that? Using for each loop simply. Okay, so what is the data type? It's string, right? String str. What is the list? lst, and simply sys out lst, right? If we run it, we'll get what? Subham Punam. Okay, we will not put lst, it is str, sorry. See, Subham, Punam and Tom. This is what we have written or we have inserted inside list, right? And the same for linked list also. Same for linked list also, right? Now set. Set has no index. It's not not an index-based data structure. Let me. So how to declare set? It's same as list st equal to new hash set. First thing, hash set. Okay, hash set has no insertion order, right? So st dot add okay, and again let me create a duplicate entry here. Let me create a duplicate entry here. It is simply same. Then let me change the value. Value is Punam Tom Harry, right? Now if we want to get those values using some indexes, suppose for int I equal to 0, I is less than st dot size I plus plus, then sys out st dot get. See, there is no get method. There is no get method. If I am using some lst list, right? Lst dot get, there will be get index, but for set there will be no get method. Okay, so for that we will need, we can use for each loop. Other than that, using the iterable interface, because we have seen all the collections are actually a child interface of iterable interface, right? So how to use iterable interface? So for that, iterator is javautil iterator. Okay, iterator string itr equal to st dot iterator, st dot iterator, right? Now in next line we'll check while and the condition is, while condition is itr dot has next. If it has some next element or more element, right? If it is true, then we'll simply print itr dot next. That's it, right? So this is how iterable interface is used. Iterable interface is used using iterated interface. If you see, this is iterable is introduced in 1.2. okay, iterable was introduced in Java 1.2. just hover over it. Okay, fine. If we run it, what we will get? See, Tom, Punam, Harry, Suam. Okay, because it is not, and just see, there are Suam twice, but in when we are fetching that particular data or particular set data, Suam is only once, because set doesn't allow duplication. Right? Okay, fine. Now if it is, instead of hash set, if we put here tree set, because tree set is a sorted set. Tree set, then what will happen? See, it is the elements are now sorted in some order. Okay, it is sorted in some order. Okay, because tree set is a sorted set. Tree set is a sorted set. Okay, now I want to reverse the order. How to do that? It's simple. We have to make use of collections class. Collections class dot reverse. Okay, reverse is this particular set st. Sorry, reverse cannot be used in set, because set is an unordered data structure. It can be used in list. It can be used in I mean, it should be list basically, because list is only the index based set. Sorry, index based data structure, right? So okay, now one thing is pending. Now the pending thing is linked hash set, right? Linked hash set. Linked hash set. Linked hash set. So if it is, the set is a linked hash set, then the insertion order will be preserved as per the theory, correct? So if we run it, see, the insertion order is preserved here. Insertion order is preserved here. Okay, insertion order preserved here. So that is how set works, that is how list works, right? Now next thing is map. Okay, map doesn't comes directly under collection framework, but collections class methods or the static methods can act on map also. That is why they are connected but not the same thing. Okay, now let me create another class called map.tut.java. Okay, now main method, public static void main. How to declare map? A simple map, then a type of key, suppose integer, and value is string, right? And suppose this is the variable name is map equal to new. First start with hash map, right? Okay, hash map. We are mentioning here key and value. Now how to add some data here? It's simple, map dot put integer key is suppose 1 and value is some string, let's say suam. Okay, then map dot put number 2 ABC, any string. Map dot put, again the key will be 2 duplicate key and value would be DEF. Now just see what will happen if we just do that, do like this. Okay, the keys are duplicate, then what will happen if we fetch it? Okay, if we fetch it like let's say map dot get, right? Map dot get, let's say value is 2, sorry, key is 2. So sys out map get 2. So what will be the value? The value will be, see, DEF. The last value has overridden this particular value. Okay, it will not get any errors, it will not get any compilation error, but the latest value will override the previous value. Okay, this is how map works. It is a key value pair things. Okay, this is hash map basically. So if we fetch all the data, it's very tricky how to fetch the data, right? Map uh, cannot be uh, iterated using some iterable interface. Okay, directly. Okay, we have to convert this map to some of the collection interface. Okay, so for that, for okay, we'll put entry, sorry, map dot entry. Okay, entry is an interface with integers and value is string. Okay, then entry map dot entry set. This statement is converting this map into some collection things. Okay, so entry set is basically we are converting this map into a set. Okay, then we can have this access. Okay, access or iterate. We can iterate the map like is entry dot get key. Okay, and this is how it works. entry dot get value. Simple. If we run it, then see 1 is Suam, 2 is DEF. Because 2, this 2 will be overridden. This particular 2, key 2 will be overridden by DEF. And the same way, if we put some other values also, three A B C D E F IJK suppose, and if we run it, then we'll put 1, 2 and 3. Now if we put some null key here, see it is getting allowed, and instead of IJK LMNO, something like that. Okay, if we run, then see null is LMNO Suvom DEF IJK. See, it is not maintaining the insertion order, it is any order basically. It is not maintaining the insertion order. To maintain the insertion order, what we have to use? Linked hash map. Okay, linked hash map. Correct? If we run the same thing, then see insertion order is maintained Suvom DEF IJK and then null key wala things, right? Now if I want these map to be sorted, then what? Then we have to create tree map, right? Tree map. Instead of hash map, we have to create a tree map. If we run it, see, it is throwing null pointer exception because we have already discussed tree map cannot contain any null key. Tree map cannot contain any null key. Instead of null, let me put some value 4. If we run, then see 1, 2, 3, 4. This 1, 2, 3, 4 is basically the ascending order of keys. So tree map is a sorted map and it is sorted in ascending order. Right? Fine. So that's all I think for this particular session. Hope you have find this particular session easy to understand. If you are not understanding anything, please do comment. Please do let me know if you are not understanding anything. I'll take special care for that. Okay, and that's all. Thanks for watching, and uh, uh, please subscribe to my channel for this, and then obviously you just access all the core Java materials in this particular channel, right? So that will be helpful for you for your interview purpose, for your learning purpose, for your programming, starting the programming purpose, right? So anyway, thanks for your time.